Okay, hi everybody. Um, I had questions through email, and since no one is joining the session, I'm going to just go ahead and cover some examples about conditional probability and overlapping sets. So I'll do a few examples of those, and hopefully somebody will join us with questions. Okay, so let's start with, again, I just have a few examples. This one is about ice cream. So suppose you have a group and 55% of the group like chocolate, 10% like chocolate and strawberry, and 40% like strawberry. So how many or what percentage doesn't like chocolate or strawberry? So we're going to draw pictures like this. So we're going to start slow. And again, I just, before I go to another page, I'll just do the problem up here. So we have two flavors of ice cream. We have chocolate. Let's represent that as this circle. So C for chocolate. And then strawberry. Now they overlap because there's some people that like both. Now I'm not talking about any other flavors, just chocolate and strawberry out of this group. So there is probably some people that don't like either chocolate or strawberry, but it's not asking what they like. Okay, so we're just dealing with these two flavors. Now, let's just start with our numbers. The 55% that like chocolate is in this whole circle. It's in the whole chocolate circle. And 40% that like strawberry is in this whole circle. But the 10% that like both is in this part right here, the intersection. This is both. And that's this little sliver right here. So in that little sliver is 0.10 or 10%. That's chocolate and strawberry. Okay, I'm going to go on to another screen. So let me draw this picture again. I have chocolate, and the whole circle's chocolate, the whole circle's strawberry, and this little sliver is chocolate and strawberry. So the percent that like chocolate is this whole circle is 55. Okay, that was given. The whole circle that likes strawberry, you see these numbers overlap. I don't want to count anybody twice. The percent that like both is 10%. That's just in that little sliver, 10%. But you're counting people that like strawberry too. So this part of the circle that is only chocolate is 55 minus the 10%. You don't want to count anybody that likes strawberry. So you have to subtract, this is subtraction, the 10%. This little sliver is 10%, and this half moon right here is only strawberry. It's not overlapping with both. It's not overlapping with chocolate. So this is 40% minus the 10%. You have to subtract out both. So our picture in the end looks like this. 45 is chocolate only, and that's just this half moon right here. Okay, it's just that. It's 45. This is both, so that's 10. And this half moon over here is only strawberry, so that's 30%. So here's the whole group. So the people that like neither or none of those two is outside here. Outside of the people that we already counted, they don't like either of those choices. So everything has to add up to 100%. So we have 100%, which is 1, okay, minus the 45, which is chocolate only, minus both, which is the 10%, minus the 30%, which is strawberry only. And that 1 represents 100%. So we have 100% minus 45% minus 10% minus 30%. And those are distinct areas. So when you add all those up, 75, 85, that leaves you 0.15. So 15% like neither. Okay, I see some people have joined. Hi, everybody. Please, like I said, I just started this question. I had an email question, so I was going over sets that overlap in conditional probability. So if you have a question, please go ahead, and if you can, hopefully you can hear me. I see my microphone's working. So just speak up or go ahead and just chat with me and ask a question. Okay, so in this question, again, if you joined late, let me go over this again. Let me start with the same problem. I had 55% that like chocolate. I had 10% that like both. This is about ice cream flavors, by the way. And then I had 40% that like strawberry. So the question was, how many like neither? This 55% that like chocolate, though, is this whole circle. Okay, so if you want to get only chocolate, you have to subtract, because the both is this part that's inside here. That's the 10%. So inside here is only chocolate, not any strawberry. So that would be the 55 minus 10. Okay, so let's do a conditional probability. Let's do the probability that somebody likes strawberry given they like chocolate. So this is the probability that you like strawberry given that you like chocolate. Oh, if it's given that you like chocolate, you already know you like chocolate. Okay, this is known. Then it has to come out of the 55%. Because we know we like chocolate. So the formula is the probability that you like strawberry and chocolate over the probability that you like chocolate. It has to come out of the 55% because that is what we know. And then what's the probability that you like both? Well, that's right up here, 10%. So it's 0.10 divided by 0.55. And I think a lot of people have to be careful how they round. And that's 0.1818, or I would just say 18%. There's no decimals in this problem, so our answer should not have a decimal. Or if you rounded, it would be 18.2%. But since we started up here in the original problem with just percents with no decimals, like 55%, it wasn't 55.9, then you wouldn't have a decimal on this answer. Okay, so there's an example of that. Okay, Carly, I'm struggling downstairs, so I'm hoping by watching something will click. Okay, I can go over the permutation formula. No problem. Let me, before I go over the permutation problem or the permutation formula, and I wanted to say something to you, Carly, while I have you. I answered your question that you emailed me about 2 days ago, and this morning I got an error message that you never received that reply. So I am checking with eVersity what is going on with the email, but I tried to send it back to you, so hopefully you got the email, the answer. But I did reply right away. It's just that you didn't get the answer right away.
It might not connection.
Oh, okay.
I live way out in between Malvern and Donaldson, so the only connection I have is through a cellular service, in which I put a repeater up at my house, and most days I get a decent signal, but sometimes it's just hit or miss.
Okay, all right. I'm not sure because I had another student that the email had an error when I replied right away, and then it came back with an error. So I'm going to have them look into it anyway because you need to get your answers right away, and I am answering them.
Yeah. Well, you've also got 200,000 students in one class too.
I'm trying, but we got it.
I've been doing this for years. I've never seen a class this size before. Never.
I know, it's huge.
Yeah.
It's huge. And to answer that question, we do have 2 coaches, and they do the grading.
Mm-hmm.
I do all the communication, but you are also welcome to ask Michelle or Ida, AIDA, for any questions that you have also.
Okay.
They're there to answer them, but
I'd probably wear them out. I have never in my life seen this content. This is like sand in my hand. I can walk away from I'll do hours. Be sitting there for hours going through to do just one knowledge check or something like that. Go get some water, come back, and it's all hieroglyphics. I guess numbers. I guess this style of math just isn't conducive to me. But.
Well, no, this is very challenging. Did you have the quantitative literacy class?
Yes. Yep.
Okay.
I still struggled.
No, that's understandable. I'm just saying that what should be helpful is that because I helped Lynn design that class too, and the problems are pretty much the same that we go over. So, and I know you probably don't remember all those problems, but the probability section is pretty much the same as what we covered in quantitative literacy. And I'm not minimizing it. I'm just trying to help.
Yeah, I might not have because I came from a 2-year from National Park Community College and College of Ouachita, and then decided to go ahead and get a bachelor's. So I got credit for a lot of uh, uh, English Comp 1, English Comp 1, 2, and things. So I don't
Oh,
even
okay.
see I don't even see quantitative. Now that I think about it, so what? I bet you I got credit for that first level of math.
Oh, yeah, you would have remembered it if you had it.
Yeah. So maybe that's why it's all a little bit foreign to me. And
Yeah.
it was literally 6 years ago when I took the other math class, introduction math at Kodo or MPCC. So.
Well, that's what makes it really, really difficult.
Well, it's like I told somebody the other day. My GPA is fine. That I can take a hit. I just want to be able to pass the class.
No, I understand. I'm trying to get everybody past this class. I think there needs to be more feedback with that material.
Oh yeah. But I mean, there's plenty of videos. There's plenty. I mean, the Khan Academy stuff content is awesome. I mean, his his descriptive manner is conducive to me. But like I said, I can go to bed, wake up the next morning, and it's. I mean, I don't understand. I do IT for a living. I work with octets,
Uh-huh.
hexadecimal, and this just kills me because it's so frustrating because I can't hold on to it. No matter how hard I want to.
It just takes a lot of time. It took me a long time to learn all of it too. And just think, you're learning all this material in just 6 weeks. There's a that's another
Yeah,
thing.
yeah, yeah. This is much like my Java class.
Okay, right. It's another
Yeah,
job.
yeah.
All right. Well, let me go over. Let me stick to a problem like this because again, I had email questions about it. Let me go over another example, and then I'll go on and do the permutation.
Okay.
Okay. So let's talk about. Again, if you have any questions, go ahead and chat. Let's talk about this problem right here. Let's say 45 children. I'm going to just take some easy examples. In a class, have a dog. 30 have a cat, and 18 have a dog and a cat. So the question is, what is the probability that you have a cat given that you have a dog? So this is cat given that you have a dog. Well, it's known, okay, the second thing there is known that you have a dog, so it has to come out of the 45. So that has to be your denominator. And actually, I mean, the formula is the probability that you have a cat and a dog divided by the probability you have a dog. Okay, so what's the probability you have a cat and a dog? Well, it's given, it's 18 right here. Okay, because if you have a dog and they want to know if you have a cat, then you have to have both. So that's 18, and the probability of a dog is 45. Then 18 divided by 45. Again, a lot of the problem is in rounding. This is 0.4, and that's 40%. you didn't have to round on this one. So drawing a picture, sorry, if you draw a picture, this is the dog, this is the cat, what number is going to go in the middle? Well, this right here is dog and cat, so that's going to be 18. And there's 45 that have dogs, but that's the whole circle. So this right here, this half moon on the side has to be 45 minus 18. That is this area right here. It's a half moon. And that would be dog only. So when you add the 18 back in, you get the whole circle. And the right side is cats only. So that would be 30 minus 18. So your picture actually looks like this. You don't want any numbers overlapping. That 45 minus 18 is 27. And that number represents dog only. And the 30 minus 18, the 12, that represents cat only. Okay, let's go up here. So I want, what do we want the probability that you have a dog given that you have a cat? Oh, that has to come out of how many cat owners there are. So that's going to be the probability that you have a dog and cat divided by the probability you have a cat. So it has to come out, we know you have a cat, so it has to come out of 30 people, 30 children. And then the probability or the number that have both are 18, so that's 18 out of 30, and that's going to be 60%. So there is a formula for conditional probability, but you just take it out of the numbers that are given. And the whole point in drawing these Venn diagrams, that's what those circle diagrams are called, or Venn diagrams, is to separate out the circles. And just when you put a number in a circle, it represents just that area. It doesn't represent anything overlapping that area. So you have to subtract out the things that you count twice. You don't want to count anybody twice. Okay, so, I mean, is there any more question on that? Or I can come back and do another example after I do this permutation question. But make sure you're chatting with me or talking with me if you have a microphone. I am recording this, but if you have questions on this. So before I erase this, does anybody have a question on this?
Not me.
Is that okay?
Yeah, I'm good.
You're good?
Mm-hmm.
Okay.
Yeah, I've actually got that part halfway down.
Okay, great.
It comes and goes.
Yeah, I totally get it.
This is Tracy, and I will say the same thing. I know that you and I have talked, but I feel exactly the same way he does.
No, I understand. And a lot of people, I mean, almost probably the whole class feels like that. It's just that we're, statistics is a lot of material. And to do, this is just, introductory, but still there's going to be a lot of stuff. You have to understand probability before we do the next week, which is like normal distribution, and that combines the statistics part with the probability. And You know, we're going to be doing more graphs and things. The other thing I could say about it is that don't overthink it. A lot of people are going through the material and like want to know every little thing, have to watch every little video. You don't overthink this material. Some of the stuff is challenging, but a lot of it is just whatever the first thing you think is usually the right thing in math. So don't doubt yourself about that. And I said this last week in the collaborate session. If you have an answer in your homework, I can go back and check what answer you put and see how close it is to the real answer, and then I can probably try to help you see what you did wrong just from your answer. So I can always do that if you want me to, you know, check and see what you did wrong. I really want to make sure you're getting this stuff. While I'm thinking about it, I want to answer this permutation question, and I'm going to try to type this because my writing is really hard on this. So let's talk about a permutation. A permutation is counting with order. Okay, so the difference between just choosing people on a committee, so suppose you have 10 people and you just want to choose 5 for a committee. If you're just choosing 5 for a committee, you're not doing it in any order. You're just picking 5 people. But if you're picking 5 people for president, vice president, etc., you know, 5 people that are president, vice president, parliamentarian, council, let's see, 5, secretary, 5 positions, then there's an order to that because, like, for an example, Sue as president and Ron as vice president is not the same as Sue being the VP and Don being the president. I think everybody agrees to that, that is not the same set. So you would want to say that is with order. But if you're just picking Sue and Don on a committee, it doesn't matter whether you pick Sue or Don or Sue. All right, so when I decide these things, when I look at a problem and I'm trying to count something, I always make an example. And it maybe even if it's just Sue and Don all the time, just put an example in there, make your own example up and change the order and see if it matters. And if it matters, then it's a permutation. So there are more permutations than there are combinations because you have order. You're counting Sue and Don different than Don and Sue, so there's going to be more of them. So if you look at the free online calc, it's Calc 2.0 online. In the left corner, there's NPR, and that calculator will do permutations for you. But I know I wanted to show you before we start what the formula is. Okay, so suppose we have.
What was that website again? Calc 2.0.
Balls, and they're white, red, and black. Okay, we want to pick these with order counting. So you could pick, here are your choices. You could pick white, red, black. You could pick white, black, red. You could pick red, black, white, red, white, black, red, white. I know you can't see this yet, but okay. So turns out we have 6 ways to do that. If there was no order, then you would just have white, red, black would be all your choices. It would be the same as black, white, red. If there's no order, you don't care. You're just picking 3 balls. There's only one way to do that. But with order, there's 6. So how we could count that? I do it as a fill in the blank problem. We have 3 balls, and you can do fill in the blank with order. I have 3 ways to pick the first ball. Red, I can pick, sorry, red, white, or black. So I have 3 ways to do that. Once I picked one of those, then there's 2 balls left. So I have 2 ways to pick the second ball. And then once I did that, I only have 1 way to pick the last ball. That is 6 ways.
Mm-hmm.
Now, if we had 100 balls with 100 different colors, we need a formula for that. So this is what I'm getting to. I'm getting to the formula. This can be written as 3 factorial. And that little exclamation point means that you start at that number 3 and you go down by 1 each time. And Tracy, I don't see when you have your hand up. So if you have a question, what I see in this window, I only see the chat. So I can't see when people are raising their hand to ask a question. So you can just jump right in. You're not interrupting me. Just jump right in.
Okay.
Because I can't see when people are raising their hand.
Okay.
Okay, so this is what 3 factorial is. So let me do, like, if you want to do 10 factorial, what you do is you just start at this number, whatever number it is. So here it's 10, and then you go down by 1 each time, and then you just multiply all the way down to 1. So 24 factorial would be 24, 23, 22, 21, multiply all the way down to 1. So it's just a shorthand. That's what that means. So let's say 24 factorial would be the number of ways to choose 24 objects without replacement. That means you're not putting anything back. So you have 24 ways to choose the first object. You don't put that one back once you picked it. You have 23 choices for the second object. You don't put that one back. You have 22 choices for the third, and so on, all the way down to 1. Okay, so what if we want to know number of ways to choose 3 objects out of 10 with order? That is a permutation because it has order. So we would say P, in the online calculator, you could just do 10, 3, 10 choose 3. The formula for permutation is n factorial over n minus r factorial. So in this problem, it would be 10 factorial over 10 minus 3 factorial. which would be 10 factorial over 7 factorial. So n is the number of total objects. 3 is how many you're choosing. R is how many out of the total you're choosing. So n always represents the total. So that's the formula. But let's work it out. And I want to show you that this makes sense. So I'm going to go to another screen. So I'm going to go 10 factorial over 7 factorial. Now, what is 10 factorial? Well, that's 10 times 9 times 8 times 7 times 6, all the way down to 1. And you're multiplying all those numbers together. Well, what's the bottom? The bottom is 7, 6, times 5 times 4, all the way down to 1. So, Carly, I think this is where your question is. This is the same number as above, and those numbers are going to cancel because 7 divided by 7 is 1. 6 divided by 6 is 1. 5 divided by 5 is 1, all the way down to 1. So 7 factorial and 7 factorial are going to cancel.
So then you're just using the 10, 9, 8 factorial?
Yeah, that's going to leave you with the 10, 9, 8. And does that make sense of what we talked about? Because remember the fill in the blank? If we're picking 3 objects, we have 3 blanks. We have 10 ways to choose the first one. Now this only works with order, okay? Fill in the blank only works with order.
Yeah.
And then you have 9 ways, because you've already picked one. There's only 9 things left. And then you've picked 2 for the third pick, so there's only 8 ways to choose that object. So it's the same as the fill in the blank problem.
Yeah. I don't know why it never occurred to me, and that's because I get lost in the content. But I mean, like you said, 7 divided by 7, 6 divided by 6, and that's so that's a 1. So that's why.
Right.
Okay. It makes sense right now. till I walk out the door.
Well, that's my job to make it make sense. No, this took me years too, so don't think that this is just coming off the top of my head either.
Well, and it helped put it in frame it for me when I realized that my last math class leading up to this was 6 years ago, at the junior college. So
yeah, that's quite a bit. I don't think I remember last year what I did.
Oh, Lord, yeah. 47 years of age. I told somebody the other day, it's amazing to me. I remember when in my 20s, I used to plan things for next week. Now I plan things for next year.
Yeah.
Because it goes so fast.
It changes. It changes. Yep. While we're talking, let me do a combination since I'm here. Unless, again, please chat your question or just interrupt if you have a question. A combination is no order. So let's say you want a combination, you want to choose, you have 9 things and you want to choose 2 of them. So this is not fill in the blank. You cannot do it that way because that means you're counting Sue and Don the same as Don and Sue, and that's what we want. But you can't do it as a fill in the blank. You have to do it as a formula. And it's easy to remember because combination and committee start with the same letter. So I look for easy ways to remember things. So if you're stuck, always think about a committee and see if your problem can, point towards that. But the combination formula and R, again, you can do this on that online free calculator, but the formula is n factorial over, and it's the same as permutations up to this point. That's the permutation formula. But remember, there's less combinations. There's less number of them because you're counting things twice. Like Sue Don, you're counting as Don Sue. So then you have less of them, so you're going to divide it by R again. So in our formula, we're going to do 9 factorial over 9 minus 2 factorial. 2 factorial. So let's write it out. 9, 8, 7, 6, 5, 4, 3, 2, 1 on top. This is 7 factorial, so that's going to be 7, 6. Notice I wrote it underneath. You don't have to, but I like to, so now you can see what's going to cancel. That's
yeah,
the
that
7.
helped out.
And then, yeah, and then the 2 is 2 times 1. Okay, so that's all multiplied on the bottom. 2 factorial is 2 times 1. So again, all this is going to cancel because 7 divided by 7 is 1, 6 divided by 6 is 1, 5 divided by 5 is 1. So now you have 72 divided by 2, and you can divide that 2 into 8 if you want to, and you get 36. So there'd be 36 ways to choose 2 out of 9 in no order. And also, cards usually are no order. So these are all C words. That's an easy way to remember it, because if you pick a king and an ace, that's the same as picking an ace and a king.
Yes.
So that's no order.
Come in.
I had to follow up with. Luckily, Belinda's phone call wasn't anything about the invoice. She said, I'm gonna resubmit it. She said, I think everything's good. She said, it just
Okay,
threw me for a loop.
Are there any
The
other
base
questions?
didn't match up to the whatever.
Mm-hmm.
Anyway, so she wanted to follow up
Mine knows their mic is
about
on.
calling in for dinner.
Okay.
And
Okay, looks like you're on you're on a speakerphone or something. I hear
any
you.
details of that? I said,
I hope that's not HIPAA compliant.
You don't want me to put you in contact with her. She's like, no, I don't think so. She said, but
Does
Tanner,
that help with the
she said, I don't
permutation?
think it should be swept under the rug.
I think the permutation formula.
But Tanner not to worry about it.
But here's the point I'm at. It has nothing to do with us anymore. That's her.
Tracy, you're on the
So
microphone.
she said Tanner's going to be giving you a call.
Okay, I muted that. All right, anything else that you want to go over, I think?
Oh, ma'am. I mean, that helped a lot, especially when you lined them up the way you did, one over the other. And like I said, I'll just keep pushing forward and going through it. I'm probably going to. Well, I've got to drive up to Rogers tomorrow for a site audit, so I won't be back till Friday. But what I'll usually do is put on those YouTube videos while I drive. And
Okay.
Yeah, and listen to them.
That's a good idea.
Yeah, because it's like 4 hours, and I get to repeat over and over and over, and
that's what you have to do, is you just have to work problems over and over. And here's the good news. The midterm, which is after week 3, is based on all the homework. So if you've been printing out the homework, it's going to be the same types of questions, if not the same questions.
Yeah. Well,
So
I just keep going over, so.
Okay, yeah, and if you come across any other questions, you can email me and I'll answer them tomorrow night, because I'll be on tomorrow night too, or just join us tomorrow night. But if you run into anything else, just I'll be happy to go over it again.
Okay. All right, thank you, ma'am. I hate to run, but it looks like I've got a switchboard that went down.
Okay, no problem. Thanks for joining.
Thank you. Yes, ma'am. Thank you. Bye-bye.
Okay, let's see. So I guess let's go over a conditional probability one more time. So let's say at a school, 60% play baseball. I'm going to do one more example, and then we can see if there's more questions. Say 25% play baseball and football. They're on both teams. So what percent of those that play baseball also play football? Well, so that would be given as the probability, because probability is the same as percent. The probability, okay, this is what we know. We know they play baseball. So of those that play baseball, this is the given. We know that. What are the chances they play football? So what we want to know is how many play football and baseball at the same time, because if it's given they play baseball and we want to know how many of those play football, they have to play both. Hold on. It's probability that you play baseball given they play probability you play football given you play baseball. This part's given. That's the question. And the formula is the probability you do both divided by the probability you play baseball. So in the problem, it said 24% did both, and the probability that you played baseball was 60%. That was given in the problem. So we do that on our calculator, and that is 0.4 or 40%. So probability can be represented by a decimal or a percent. And the probability, okay, we don't know what percent just played football, so we can't switch that around. But I guess we could. We could say the probability that you play football, let's just make this up, is 50%. So the probability, again, I'm just made that up. The probability that you play baseball given that you play football is the probability that you play baseball and football divided by the probability of football. So whatever we know football goes in the denominator. So baseball and football, again, is 24%. That was given in the problem. And probability you play football, again, I just made that up, is 50%. So this answer would be 48%. Or 0.48. Now in the homework, it should say whether it wants a decimal or a percentage. So you have to read really carefully what they want. And again, I can go back and look at your homework and look at your answer and try to figure out what you did wrong. I can't do that all the time. I mean, I can look at your answer all the time, but I can't figure out what you did wrong all the time. Okay, so this session was about conditional probability percentage, permutations and combinations. So if you have any other questions I can go over tomorrow night, I'm sure you'll come across some. So please don't hesitate to email me or email me any anything you want to go over more. I can get some more examples. I don't have to go over just the homework. I can make up examples that might help also. Okay, I guess there's no other questions, so I am going to end this session. And if you have anything else to talk about, please don't hesitate to contact me, and I'll try my best to get an answer for you.